Okay, here's a small DC motor I made. It's actually alternating DC input to it. It has a rotor similar to this with 4 north-south magnets, north-south, north-south. The magnets actually show on both sides in the rotor I have in the motor. This happens to have this plastic backing. Coils will stretch. Before coils in between each magnet, and they will stretch across the two magnets, adjacent magnets. So this one will be north, this one will be south, so when you energize the coil it'll pull it and push at the same time, so it reacts to two magnets at once, so you get twice the power as compared to just a single coil against a single magnet. So it has to be alternating DC input for this to keep going, so that's what I have. And so I built a H switcher down here. It's 4 solid state relays. 2 send in power one way, 2 the other way. It's timed with a timing disc here with a small row of very small magnets at 180 degrees apart, and then a Hall effect here and a Hall effect here at 90 degrees apart. So one Hall effect controls 2 of the relays that send power in one way, and the other Hall effect controls the other 2 relays. Here's the DC to DC boost converter, and I have 12-volt battery over here, and that inputs to the boost converter, and then I boost up the voltage up to 49 volts it says while it's running. But when I slow this motor down, back here, just grabbing this back here, slowing it down, it goes up to 71 volts on the output of the boost converter going to the motor, and current goes down instead of going up when I slow the motor. Here's the meter for current. I'm measuring directly from the battery to the boost converter. Here's the meter for voltage. And so right now it has 47 volts going into the motor, but it's overall drawing about 24 watts because it's about 2 amp draw with a 12-volt battery. So watch this. I will slow the rotor down and film both meters at the same time. Hold on. Okay, here we go. This is current. It's almost 2 amps. This is voltage coming out of the boost converter. I'm going to reach back there and slow it. This should go down to about 1.5. This should go up to about 70. Okay, you see that? Now when I do not load the shaft, it goes back to these numbers. I'll do it one more time. Okay, so that's pretty interesting. Not sure why. So thanks for watching. Okay.